Good evening, friends, brothers, and comrades. This is Evan Alpaca with the second part of my Manned Mission to Eve series. In the first part of the series, we got an overview of the two launches that are going to comprise this mission, and we did the first launch into orbit around Kerbin, which was the Eve lander. The second launch is going to be the tug that will push it around space, and this will be done with the Spaceplane SSTO. If you haven't watched the first part, I would recommend you start with that one. Let's get flying. In a previous mission, I launched a 100-ton payload to Kerbin orbit with this spaceplane. This is only about 85 tons, so we should have plenty of leeway. We just got some pre-flight to do. I neglected to put the nuclear engines in a different stage. We don't want them firing right away. And we also want to disable the cross feed here so we're not using liquid fuel from the tug in the cargo bay. Now, since our goal is actually to dock with the lander, we want to launch a little bit ahead of it. If we launch into a lower orbit than this, we will be moving at a higher angular velocity, and if we're higher than it, we'll be at a lower angular velocity. There's more room on the top side of this because this is at a relatively low orbit, so we want to move at a higher orbit than this, at which point it will be catching up to us, so we want to be ahead of it. So we're going to speed up. And we have plenty of fuel of this, so the only thing, if we launch too far away from this, it'll just take a little bit more time to get there. But we don't want to take forever, so we'll let it get fairly close to us. Space planes do take a little while to take off, so we don't want to wait too long. That looks about good. Well, let's get going. I want to turn the brakes off, that would help. Stability mode on and the cargo bay closed. Now the turbo ramjets and the Rapier engines are interesting in that they generate more thrust at lower altitude than higher altitude because they have more air. But they also generate more thrust if you're going quickly. You can't really go quickly at surface levels, at sea level I should say, because the air is just giving you a lot of drag, it's generating a lot of heat. And if you could manage to break through the drag, you'd probably burn up and die. So we're going to head to a reasonable altitude, about 8 kilometers, and then we're going to drop to level, to horizontal flight, and pick up a bunch of speed. Always remember to put your gears up. I know it doesn't make an actual aerodynamic difference in Kerbal, but it just looks wrong. We are staying level for now because in order to climb quickly we want to be going faster, so we are generating more thrust. So we're going to pick up speed until we're close to 300 meters per second, then climb to 8 kilometers, at which point we'll really pick up some speed. Alright, we are almost 250. Let's start climbing now. We're going to put the nose at a little bit under 30 degrees. And we accidentally put a little bit of yaw in there, so let's correct that out. Get it back to 90 degrees, exactly east. Especially because we're docking. We don't want to have any sort of angular difference in our orbit. We want to be orbiting on the same plane. Alright, so we're heading up fairly even. Our vertical speed's almost to 100. I would have liked it to be at 100, but oh well. And we can see our thrust is falling because we're getting higher. Now generally most people do use around 8 kilometers to 10 kilometers as the good altitude for really picking up speed with these jets. It's generally more efficient if you do it a little bit higher in that range, but since we're not at the max payload, but we still have a fairly significant payload, if we waited until 10 kilometers, I don't think we would have enough power to pick up speed without losing altitude. We can see the thrust is dropping. That's probably going to drop to around 1K before we start leveling out. And we're starting to lose some speed. But that's alright. We're still climbing at a reasonable rate. Let's drop the nose a little bit now. But anytime, space planes, obviously they take some time to get into orbit, but anytime you can use them, they are the way to go. This is almost without exception, the most efficient way to get a payload into orbit. Obviously, if it's too bulky, it's not going to fit inside the Mk3 cargo bay, but if it can fit in an Mk3 cargo bay, this is the way to do it. Since you're landing on the runway, you're salvaging the entire cost of the parts and you're only paying for fuel. Now you can see our vertical speed's a little under 0. That's fine, we're not losing that much altitude, and it's starting to go up. Having Kerbal Flight Engineer is very, very helpful for flying space planes like this, especially the thrust is useful to see. That way you know when to switch mode over to closed cycle. And it's very useful just to have the horizontal speed versus vertical speed, as well as being able to see your apoapsis height while in staging mode. Alright, so we are starting to pick up some real speed here. Our thrust is starting to get back towards 2K. Once this gets a little higher, not only is our speed going to keep increasing, but our acceleration is going to get higher as well. Our goal here with the climb, we don't want to spend too much time in the atmosphere, because when you're in the atmosphere you're doing work against drag that's generating heat, that's wasted energy. However, the air-breathing engines are so much more efficient than rocket engines that we want to spend enough time in the atmosphere, when we're in an atmosphere that has enough air in it to really be generating a lot of thrust, that we don't have to use the rocket engines for more than we have to. Our goal is we want to hit around Mach 5 while we're still on the air-breathing engines. Maybe a little less. You start to burn up when you get much above that, even if you're in the less dense part of the atmosphere. But we can see our G-force is climbing, our thrust is almost up to 3K. This spaceplane also should have plenty of fuel left over. Even with the 100-ton payload, there was enough fuel left over to do a little bit of maneuvering in orbit and still land. You don't really need that much delta V to move around in Kerbin's orbit. If we look at NASA's real-life space shuttle missions, they had very little delta V for actual orbital maneuvers. Almost all of it was just getting out of Earth's gravity. I should say out of Earth's atmosphere. Obviously it's still in its gravity if it's orbiting. Alright, we're nearing 100 meters per second vertical. We're going to let the nose fall a little bit. We don't want to climb too fast. We want to spend enough time in the atmosphere that we pick up more speed. I'm actually going to let it fall a little bit more because our speed is not even to Mach 3 yet. And once you get past 12 kilometers, you really start losing thrust due to the less dense air. And as I said, we're not going nearly fast enough yet. But that's fine because our thrust is still climbing. And now it is falling off a little bit, which is fine. We still should get well above Mach 4. And while our thrust is falling, the air drag is also falling. So we'll continue to speed up. And we're not hitting Mach 5, which is fine. We're most of the way to it, which is perfectly fine. Once our thrust drops to around 50 kilonewtons per engine, we're going to switch over to rocket mode. We've got 12 engines, that'll be around 600 kilonewtons. Maybe a little earlier. We don't want our G-force to get negative. We don't want to actually be slowing down. So when I see this starting to potentially slow down, I will switch over to the rocket engines. Always make sure when you're using these engines, the Rapiers, that you do have it hotkeyed so you can switch mode with one button. I also hotkey the intakes to close and open. I'm not actually sure if you're more aerodynamic with them closed, but I close them anyway. Our thrust is getting down there. We're about ready to switch. You can see our acceleration's reached around 0, so we're going to switch now, switch the intakes, and we're back to climbing. I'm going to let the nose fall a little bit, just as a little bit of correction. We're going to climb until at this attitude until our time to apoapsis is around 1 minute, which should be around 30 kilometers. At that point, we're going to let the nose fall to prograde, and it will stay there until we are in orbit. The orbit of our lander was around 80 kilometers, so we want to be a little higher than that. Alright, our time to apoapsis is around 1 minute. Let's let this fall to prograde. You can see our time to apoapsis is increasing, even though we are flying prograde, which is exactly what we want it to do. If your time to apoapsis is decreasing, that means you're probably going to start falling back to Earth. Or Kerbin, I should say. Kerbals have no idea what Earth is. I think. I hope so. Because if their space program is any sign, they're pretty inventive. I don't know if I really want to take them on. Looks good. Alright, and now we have some downtime. You could put it on physics warp, but in my experience, oftentimes putting physics warp causes problems with space planes. They start to get wobbly when they shouldn't get wobbly. But I reckon we'll be safe with a nice 2x. And let's see. Oh dear, it appears to have gotten in front of us. Well, that's what happens when you use a space plane. Sometimes they take so long to launch that it just gets right in front of you. No worries. We're just going to go to a lower orbit. I did say that's less convenient, and it is, but we have plenty of leeway in here. And there should be room for us to fall in an orbit lower than it and be able to catch up to it. So we're going to put that periapsis right down by 70 kilometers. Obviously, we want a little bit of leeway because falling into the atmosphere, even the upper atmosphere, can be very inconvenient. Especially if you're on time warp. In my experience, if you go through the atmosphere and still have time warp on, sometimes it slows down like it's supposed to, and other times your machine just falls apart. By the way, to get to Eve, I'm using a little mod called Transfer Window Planner. It's very invaluable. There are some online versions of it that you can just use in your browser, but this is just more convenient because it's right inside the game. It's a little calculator similar to how you calculate maneuver nodes that just lets you pick a origin, a destination, and it tells you when you need to leave to get to a planet. Drop the nose down a little bit so we're actually burning in the right direction. You may notice with space planes you end up with very small burns as an insertion burn into orbit. Since we picked up as much horizontal speed in the atmosphere as possible, we don't need to do that much more in space, which is great because rocket engines are inefficient. Relatively. We'll center the burn around the node. Excellent. Oh, periapsis is still a little below 70. Excellent. I'm keeping that as low as possible because we really want to catch up to this. And our apoapsis is actually higher than this right now. I'm going to decrease the apoapsis at the periapsis. That's a little bit of wasted fuel, but as I said, we have plenty of extra room in here, so little mistakes like that are not going to cost us that badly. So let's write out that maneuver node now. I'm going to decrease that to, sure, 73, why not? Alright, and let's warp to that. While we got a little bit of downtime, another mod, I mentioned this in part 1, really do use HyperEdit. It's a wonderful mod. I don't understand how you do complicated missions without testing some things first. We're going to burn this nice and slow because this is not a big burn. Just a little correction burn to make up for the fact that I launched too late. Alright, we're at a lower orbit and we're going to catch up to this. Let's set it as a target. We can see it's 132 kilometers there, 94 over there. So we're catching up, which makes sense because that's how physics works, both in the real world and in Kerbin. So that's 94, that's 30. Once we pass this, we'll see how close we're going to get. We should pass it sometimes between here and here. So we'll pass it around there sometime in the next orbit. Alright, let's slow it down. Let it recalculate. Okay, it's saying 10 kilometers there. The cones seem to have placed right above each other, which is kind of inconvenient. We have a little bit of an ascending node, so let's do our maneuver on there, just so we can get rid of that and get on to the same plane. $16.1 kilometers. Let's get that a little lower. Oh, wrong way. 13.1. .6. Alright, let's put it somewhere in there. 12.6. We could muck around a little bit with the radial, but since we're so close to the planet Kerbin, we do want to be very careful with that. If we muck around it too much, we could actually put part of the orbit below 70 kilometers. That is not something that we want. So let's leave it at that for now. We can do another burn later. One thing about the Spaceplane is I wanted to keep things as light as possible so it can lift as much as possible, and it does not have that much torque to maneuver with in space. Alright, let's accelerate to our node. Let's see, we are catching up. At this point, I proceed to muck around a bit with some maneuver nodes to get my docking closer. I am going to edit some of this out. And for your viewing pleasure, I have put the docking process in fast forward so you do not have to suffer through the technically worst docking maneuver in the history of KSP. 14.1 kilometers. Now we can narrow that down a little bit. That we have that docked, our mission is ready to head out to Eve. We're going to leave the cargo space plane in orbit around Kerbin, because on our way back we're going to dock the tug back inside that cargo bay in order to land it. Now, in order to calculate the most efficient time to leave, you could calculate it yourself. You could look something up online. But the most efficient way to do it is to use Transfer Window Planner. It's a very handy-dandy app. We just type in the destination that we want when we want to go, plot it, and it'll tell us when we need to leave, which is year 8, day 284, which is about 270 days away. So we're going to have to fast forward time quite a bit. And I think I'm going to split this now and make that part of part 3. So this has been Manned Mission to Eve part 2 with Evermore Alpaca. Thank you very much for watching, and please leave any comments you have below.